This is part 2 of adding and subtracting rational expressions. Right, and what we're going to do is we're going to take the same ideas we developed last time and do a little bit more complicated examples. Alright, so let's say we want to add these two rational expressions. Right, we're going to apply the same principles that we had from part 1. Alright, so first thing, let's factor our denominators. Alright, so for the first fraction we have x minus 1 over this, right? And I'm not going to take the time to show all the steps with this, right? You should know how to factor that, right? But this we can factor using our magic x strategy. So that's going to end up being x plus 3 times x plus 1. All right, for the second fraction, we have x over, and x squared minus 9, that factors as x minus 3 times x plus 3. Okay, so we have both our fractions factored. Okay, and remember, in order to add these fractions together, we need our denominators to be the same. So we need to have the same factors in the denominator. All right, so looking at the first fraction, all right, so let's ask ourselves, what does the second fraction have that's missing over here? Right, and I notice over here, there's a factor of x minus 3 that I don't have over here. So I need to multiply the first fraction by x minus 3 over x minus 3. Now, for the second fraction, right, we need to get this denominator to match over here. Right, so what's missing? Well, on this side, I'm missing an x plus 1. So I need to multiply by x plus 1 over x plus 1. Okay? All right, so now let's work this out. So I'm going to do the one on the second fraction because it's easier. Right? If I multiply the top, I have x times x plus 1. And that's going to be x squared plus x. Right? And I can just leave this like this. Okay. Now for the first fraction, right, we need to multiply x minus 3 times x minus 1. Okay, and you just treat this like normal. X minus 3 times x minus 1, so that would be x squared minus x minus 3x plus 3 over this. Okay, and now that they have the same denominators, we can just add all of this together. Okay, so if we combine like terms and add that all up, what are we going to have? We will have x squared plus x squared is 2x squared. And then we have negative x and negative 3x plus 1 more x. So that's going to be negative 3x plus 3. And that right there would be our answer. For the second one, I would like you to do this one on your own. All right? So use the same strategy. Factor your denominator, get a common denominator, and then add everything together. Okay, so please pause and do this one on your own. All right, let's check to see how you did. All right, so first let's factor our denominators. The first denominator, you should factor this way, 3x times x plus 6. The second one, you're going to use your magic x. That factors as x plus 6 times x minus 2. All right, so now let's see what's missing in the first denominator, right? What does the second denominator have that I don't have over here? And what it's missing is an x minus 2. So I need to multiply by x minus 2 over x minus 2. For the second one, what do I have missing? I'm missing a factor of 3x. So I need to multiply by 3x over 3x. Okay, so now our denominator is 3x times x minus 2 times x plus 6. Right? If you multiply these two, right, probably want to put these in parentheses, then you should have x squared plus 5x minus 2x minus 10. And then for the second one, same denominator as the first, but 4x times 3x is 12x squared. So now if I add everything together, we have 13x squared plus 3x minus 10 over all of this. There's your answer. All right, last one. We'll do this one together because it's a little bit tricky. All right, so first, let's factor our denominators. So down here, let's see, what can I do? I can factor out a greatest common factor. I can pull out a 4x. So let's see, this would be 4x times the quantity 2x plus 5. All right, and then the second one, 5 is not going to change, but the denominator, 6x squared, that can be factored as 3 times 2 times x times x. Okay, all right, so now let's get the same denominator. Oh, actually, I also notice here that this 4, right, that 4 could be factored, right? So this is something important, right? We pull out the 4x first, but you can also factor it one more time. So let me write this out again. I'm going to write this as 9 over 2 times x times 2x plus 5 minus 5 over 3 times 2 times x. All right, so now we're ready. So let's see. What is missing here? What do I have in the second fraction that I don't have here in this denominator? Okay, and it looks like I'm missing a 3 and also an x. So I'm going to multiply by 3x over 3x. Okay, now let's see, what's missing over here? Okay, so it looks like I'm missing a 2, so I'll multiply by 2 over 2, and I'm also missing this 2x plus 5. So I need to multiply by 2x plus 5 over 2x plus 5. Oops, sorry about that. All right, so let's multiply this out. Okay, so on the top here, 3x times 9, that's 27x. Okay, now the bottom here, it's a little bit messy. Let's multiply our constants first, right? 3 times 2 is 6, times 2 is 12, so this is 12. And then I have two factors of x, so that's 12x squared times 2x plus 5. Okay, this denominator should be the same, so 12x squared times 2x plus 5. Okay, now for the top, you have to be a little bit careful, right? So we have 5 times 2 times 2x plus 5. Right, so what I would do is I would multiply these two first. So that's 5 times 2 is 10. So it really is 10 times 2x plus 5. Right, and if you distribute that 10, that would be 20x plus 50. All right, and lastly, we have to subtract. Okay, now you always have to be careful because we're not just subtracting the 20x, we're subtracting this whole thing, right? So to really show this work, I would do this. I would show it 27x minus this quantity, 20x plus 50, over all of this, 12x squared times 2x plus 5. Right? And so this will end up as 27x minus 20x and minus 50 all over this. All right, which gives us a final answer of 7x minus 50 over 12x squared times 2x plus 5. And there you go. All right, we'll do some more of these in class.